Good afternoon, everybody. Apologies for the delay in the release of this video. I blew up some components and had to do some troubleshooting. So this is the circuit that we talked about in the last video for the Workbench lights, where I went through this and talked about how the linear mode linear mode constant current driver for the LEDs works. So I was doing some proof of concept in the background and put it all together, put power on it, and immediately let the smoke out of that transistor. I was a little dismayed, whipped it out of the board, did some troubleshooting. I made a really dumb mistake. I fixed that, put it all back together, and it still wasn't working. These resistors here, which set the current, were getting super crazy hot, and it made no sense because they shouldn't be getting super crazy hot. And so I double checked the wiring and everything was fine, and I just couldn't figure out what was going on. So I just tore the whole thing to bits again and went through and tested all the components, and it turned out that I had also killed this Zener diode, and that made the whole thing stop working. So I actually have this driving the light for my Workbench currently, so I have the exposure set to auto, but you can see I just made it brighter. And you can see it pulsates a little bit as it settles into its current. That's a side effect of the way the circuit works. But it settles in and then becomes a steady illumination, and that's all the way down. Anyway, so I just wanted to show you guys real quick. This is a little component tester I built. I'll put a card up here for it a while back. And it's actually a very neat little toy. So I'm going to go ahead and plug this Zener diode in and activate it, and it's going to go through its little testing routine, and it says it's a resistor. That's not right. Now I'll go ahead and throw a healthy Zener diode in here and make it go through its testing routine again, and boink. It doesn't quite know what a diode or what a Zener diode is, but it's smart enough to realize that it looks like two diodes end to end, one with a forward voltage of 4.58 volts, that's a little bit lower than expected, and one with a forward voltage of 700 millivolts. And I just remembered that the reverse bias voltage of the Zener diode is actually this plus this, so 4.5 plus 0.7 is 5.1, which is exactly what it should be. Anyway, so that's what a healthy Zener diode looks like. And then there was also the transistor. I tested that one, and it also shows as a resistor, which is not correct. I'll show you what this is. An identical transistor from the same package that I did not let the smoke out of. Get into the thing. There we go. And push the button. And it goes through. It says it's a bipolar junction transistor, NPN. That's correct. It's got a beta of 495, which is a very high amplification. It's got a forward voltage of 0.65 volts, and it also gives you a nice little diagram of which pins are arranged as to which slots they're in. That's very nice for component identification. That's what this is primarily used for. Although, for a $7 tester, it gives fairly accurate readings on stats. So that's what a healthy transistor looks like. Now let's plug a MOSFET in. Now I didn't figure, if it didn't know how to identify a Zener diode, I didn't figure it was going to identify a MOSFET, but lo and behold, it actually knows what a MOSFET is. So it's saying it's an N-junction MOSFET. It gives it gives the complicated diagram. That's what I should have drawn on this, but I did the cheater's version of it. It tells you what the parasitic capacitance is, and we'll talk about those in another video sometime in the future, and gives you various other stats that are actually really close to what the datasheet says those stats should be. So I was very pleased to see that it can do that. Anyway, that was just a little bit of an update on the project here. An interesting quirk about this circuit is that it is at its most efficient when the light is all the way bright. This runs nice and cool. Oh, it's a little warm. There's no appreciable heat coming out of the current sense transistor. There's no appreciable heat coming out of the current sense resistors, and there shouldn't be any heat coming out of these because there's picoamps or microamps going through those. And I don't actually have my 500K resistor, I only had a 330K, but it works just fine. Now here's where it gets weird. If I take this and I turn this down, like so, my poor white balance is going crazy, this actually starts getting hotter. And the reason for that is that this is a linear mode constant current driver, which means that any excess current that isn't being dissipated by the light has to go somewhere. So that all gets dissipated through this MOSFET. So the way I'm using it, the MOSFET is acting as a very smart resistor that adjusts itself to control the current going through the LEDs. So when I turn this down to reduce the amount of current going through the lamp, that extra power has to be dissipated through the MOSFET. So the MOSFET runs at its most efficient at the max brightness. So that's kind of an interesting little quirk that I noticed while I was playing around with it. Now it's getting fairly warm, but that's to be expected. This MOSFET can dissipate, according to the stats on it, I believe it's 60 amps that this MOSFET can operate with, but you'd need a really big honkin' heatsink for it. I just have this little modest heatsink because we're only operating it at a maximum of about maybe an amp. It might be dissipating at its absolute max. But anyway, just a little bit of interesting information there. I won't be able to do a follow-up video on this quite yet. Due to budgetary constraints, I haven't been able to order the rest of the equipment I need to finish building these. And that's where this next part where I beg for money comes out. I don't like having to do this, but being as I can't monetize my videos, I have to do this. So anyway, if you liked, give me a like, ask any questions you have in the comments below. Click here to subscribe, that's important. Once I get to 1,000 subscribers, I can actually start monetizing my videos and maybe making money. I'll put a link to a video that YouTube thinks you'll find interesting there. The playlist for these Workbench lights is there. And right here is my Patreon where you can help me out with those budgetary constraints. And I will be forever grateful to anyone that signs up. So in advance, anybody who signs up, thank you very much for helping, and I'll see you in the further videos. Bye-bye.